All right, welcome back to the deep dive. So today we're jumping into something super specific but really crucial for physical security. We're looking at niche monitoring systems, and specifically the NTI E-GBS glass break detection sensor.
Yeah, this is the definition of a specialized tool. Our mission today is really to unpack why it's built this way. It's not just about what it does, but, how it solves problems unique to places like data centers.
And it doesn't work on its own, right? This has to plug into an NTI Enviro-UX system.
That's the key. The Enviro-UX is the brain of the operation, handling everything from temperature to, well, this. The EGBS sensor connects right into units like the NANIC-MI&I, the NAGIS-5D, or the NAGIS-16D.
So it uses that central hub for power and for sending alerts.
Exactly. It's all about creating one robust, centralized system that notifies an administrator when something happens.
Okay, let's get into its main job. It's an acoustic sensor. It listens for the cracking of glass.
And specific types of glass, too.
Yeah.
Plate, tempered, wired, laminate. The common stuff you'd find in a framed window.
But here's the thing that I keep coming back to. Server rooms are incredibly loud. How does this little microphone tell the difference between a cooling fan and an actual window breaking?
That is the million-dollar question, and it's where the engineering gets really smart. It's not just about volume. The EGBS has adjustable sensitivity, but more importantly, it uses digital signal processing, DSP.
Okay, so DSP, what does that actually do?
It lets the sensor filter out all that constant low-frequency noise,
Yeah.
the hum from the HVAC systems.
Yeah?
It's trained to ignore that and listen only for the very specific high-frequency sound of shattering glass.
So it's basically noise canceling for everything except its target sound. That's the real magic here.
It really is. It turns all that background noise into a non-issue, which is critical for avoiding false alarms.
Now let's talk about the physical side of this. The detection range is only 25 feet.
Right. And the documentation is very clear that things like drapes or blinds will reduce that signal.
Which makes sense. You're basically dealing with a highly sensitive microphone. Soft materials are going to absorb that sound.
Exactly. You have to treat that 25-foot field like a clear, unobstructed zone if you want it to work reliably. The good news is that it comes with mounting hardware for walls and ceilings, so you have some flexibility there.
So once it hears that specific sound, how does it physically, get that signal back to the Enviro-UX?
It's pretty versatile.
Yeah.
It connects the screw terminals on the main unit. You can wire it to a dedicated digital input, or you can connect it to one of the RJ45 sensor ports.
Okay, so you have two main options there. For the digital inputs, I'm guessing that's just a simple two-wire cable.
Yep, a standard 22 AWG 2-wire cable does the trick. But if you already have network drops nearby, you could just use a standard CT5 or CT6 cable with an RJ45 connector on the end.
That's a huge deal for installers.
Oh, absolutely. And the max cable length is pretty incredible. 1,000 feet.
Wow, 305 meters. It covers even some really sprawling facilities.
It does. And remember, the sensor is powered directly by the Enviro-UX units, the E2D, 5D, and 16D. So you don't need to worry about running a separate power line to the sensor, which just simplifies everything.
Okay, so let's tie this all together. The price is listed at $125. It's got a 2-year NTI warranty, and it's TAA compliant. So for the security pro listening, what's the final takeaway?
I mean, the EGBS is a scalpel. It's a highly specialized acoustic layer for a very specific problem. It's designed to detect a violent intrusion in an environment that is, by its nature, already incredibly loud. Its real value is using that DSP tech to do it reliably.
That nails it. It's all about reliability and avoiding those false positives. But here's a final thought I want to leave you with. We know that drapes and blinds can reduce that 25-foot acoustic field. But thinking beyond just fabric, what about other noises? I'm thinking of, a high-velocity exhaust fan or localized rack-level cooling units. If one of those is cycling on and off right inside that detection radius, could that high-amplitude noise pose a challenge that even the DSP might struggle with? Something to consider.